Right now, 3 fault systems on 3 different continents are telling scientists 3 different versions of the same warning. One already killed thousands, one killed almost nobody, at nearly the same magnitude, and one hasn't broken yet, but a new study says it's under more stress than at any point in the last 1,000 years. This is not a coincidence video. This is a pattern with an actual explanation, stay to the end, because the last part of this is the one that should worry you the most. Welcome to Infinity Alert. Today we're breaking down 3 major earthquakes, one brutal contrast in outcomes, and one fault system scientists are watching right now with real concern. June 24th, 2026, 6:04 in the evening, northern Venezuela. The ground breaks, twice. A magnitude 7.2 then, 39 seconds later, a magnitude 7.5. 39 seconds. That's not enough time to finish reading this sentence out loud, let alone evacuate a building. The USGS calls this an earthquake doublet. 2 ruptures, almost identical seismic signatures, back to back. It's rare. And it hit shallow, 10 to 20 kilometers down, directly beneath dense coastline west of Caracas. The result? Catastrophic. As of July 15th, 2026, the most recent official count, Venezuela's National Assembly confirmed 4,829 dead, 16,740 injured, nearly 18,000 people homeless. Say that number again, 4,829 people. Recovery crews are still pulling bodies from collapsed buildings more than 3 weeks later. Now here's the part that should stop you. Less than 2 months earlier, on April 20th, 2026, Japan got hit by an earthquake in the same weight class. Initially measured at 7.4, later revised up to 7.7 by the Japan Meteorological Agency. Bigger than Venezuela's main shock. A tsunami warning went out for 3 prefectures. Bullet trains stopped mid-track. Evacuation orders hit the coast. Confirmed deaths in Japan, 0. Injuries, a handful, minor. Same category of earthquake. One outcome measured in thousands of graves. The other barely made it past the first day of the news cycle. That gap is the actual story tonight. And it's not luck. Here's what magnitude alone doesn't tell you. The scale is logarithmic. Every whole number up means roughly 32 times more energy released, not a bit more. So Japan's 7.7 actually released significantly more raw energy than Venezuela's 7.5. And Japan still walked away with 0 deaths. Why? 3 variables decide the outcome, and none of them are how big was the number. Depth. Both quakes were shallow, so that's not the difference here. Soil, loose or reclaimed ground shakes harder than bedrock. And the third variable, the one that actually explains this gap, what's built on top of the fault? Japan sits where 4 tectonic plates grind against each other, the Pacific, North American, Eurasian, and Philippine sea plates. It absorbs roughly 1,500 felt earthquakes a year. In response, Japan has spent decades engineering buildings to flex instead of snap, installing base isolators that act like giant shock absorbers under entire structures, wiring train networks to auto-brake the instant seismic sensors detect a rupture, and running an early warning system, lived since 2007, that buys residents several seconds of notice before the worst shaking lands. Seconds. That's enough time to get under a table, enough time for a surgeon to stop mid-procedure, enough time for a bullet train to start braking before it hits a bridge at 200 kilometers an hour. Venezuela had no comparable warning system running when the ground broke on June 24th, and years of economic strain meant a large share of buildings across the affected region were never reinforced to modern seismic standards in the first place. That's not a moral judgment. It's documented infrastructure history, and it's the actual mechanism behind 4,829 deaths. Remember that number. We're coming back to it. Mid-video CTA. Quick ask before we get into the part of this story that's still unfolding. If you've ever felt an earthquake, small tremor, or full building shaking chaos, drop it in the comments right now. Where were you? What did it feel like? I read every one of these, and it helps this video reach people who need to see it. Subscribe if you want to catch the next breakdown the moment something like this happens again. Now, California. In June 2026, a research team led by Lillian Burkhard, University of Hawaii at Manoa with the University of Bern, Switzerland, published a study in the Journal of Geophysical Research, Solid Earth. The subject, the San Andreas and San Jacinto fault systems in Southern California. Here's how a fault stores up disaster. 2 plates grind past each other, but friction locks the upper section in place while the deeper rock keeps moving. That locked section doesn't just sit still. It stores the strain as elastic stress, like a spring being wound tighter every year it doesn't slip. The southern San Andreas hasn't produced a major rupture since 1857. That's 160 plus years of a spring being wound with no release. Burkhard's team built a physics-based model, fed it a reconstructed 1,000-year earthquake history, radiocarbon-dated sediment shifts, tree ring records, and ran it forward to today. The result? Stress on multiple fault segments is now at or above the highest level recorded anywhere in that entire 1,000-year window. One segment specifically, San Jacinto to San Bernardino, hit the highest stress reading in the whole simulation, 3.6 megapascals, beating its previous peak from nearly 50 years ago. Then the second finding. There's a location called Cajon Pass, about 50 miles northeast of downtown Los Angeles, where the San Andreas and San Jacinto systems physically meet. Burkhard's team calls it an earthquake gate, a junction that can either stop a rupture from spreading between the two faults or let it pass through and combine into one massive multi-fault event. According to the study, ruptures cross that gate when stress on both sides reaches similarly extreme levels. Burkhard's own words, "That is the configuration we are approaching today." If that gate opens, the study says the impact zone covers Los Angeles, San Bernardino, Riverside County, and the Coachella Valley, all at once. To be precise, because this matters, this is not a prediction of when. No science on Earth can currently tell you the date of the next major earthquake. What this study establishes is that the physical stress is now at a historically extreme level. That raises probability. It does not set a countdown clock. Here's the detail that makes Japan's outcome even more remarkable. The exact stretch of coastline that shook in April 2026 is the same Japan trench system that ruptured in March 2011. Magnitude 9.0, the Tohoku earthquake, the one that killed over 22,000 people and triggered the Fukushima nuclear disaster. 15 years later, a major earthquake hits that same fault system, and the death toll is 0. That's not an accident of geology. That's what happens when a country rebuilds its entire warning infrastructure around the worst lesson it's ever been taught. Japan even issued a rare megaquake advisory after the April quake, a status used only twice since the alert system existed, because scientists know proximity to these subduction zones raises short-term risk, even without being able to name the day. So, is the planet doing something unusual right now? No. Earth produces 120 to 140 earthquakes of magnitude 6 or higher every single year, roughly one every 3 days, somewhere. Most of what we just covered sits on or near the Pacific Ring of Fire, a 40,000-kilometer arc responsible for about 90% of the world's earthquakes. Venezuela and Japan sit on completely separate, geologically unconnected fault systems thousands of kilometers apart. One did not trigger the other. The geology hasn't changed. What's changed is how many people now live directly on top of it, and in what. 3 earthquakes, 3 different stories. Venezuela, 4,829 dead and counting because the infrastructure wasn't there when the ground moved. Japan, 0 dead at a bigger magnitude because it was. And California, a fault system that a peer-reviewed study, published this June, not decades ago, says is sitting at the highest stress level in over 1,000 years, with a documented gate that could turn a bad earthquake into a catastrophic multi-fault one. Southern California hasn't had its earthquake yet. According to the data, it's not a question of whether the stress releases, it's a question of when the gate opens, and what's been built by the time it does. We'll be tracking every update out of Venezuela's recovery effort and every new reading coming out of the San Andreas system. Subscribe so you don't miss it when it happens, because based on what the data shows this month, it's not a matter of if. Thank you for watching Infinity Alert. Stay curious, stay inspired. See you in the next journey through the universe.